Hi, I'm Kathleen Hupfeld. I'm currently a PhD student in applied physiology and kinesiology at the University of Florida. In this video, I'm going to tell you just a little bit about what I do and how I got to this point. Although I spent the first 18 years of my life in Maryland, just outside of Washington, D.C., I moved to Elon, North Carolina for my undergraduate degree. At Elon, I majored in exercise science and I minored in neuroscience. Through Elon's honors program, I became very involved in neuroscience research. I worked with a faculty mentor to develop several different research projects. In these projects, I tested whether low-level brain stimulation affected motor performance in college students, military personnel, and in kids with developmental conditions like autism spectrum disorder. This involvement in research as an undergrad led to my next step, applying to graduate school. I applied to a variety of neuroscience and psychology PhD programs so that I could continue learning about the brain. Months after graduating from Elon, I moved to the University of Michigan to start as a cognitive neuroscience PhD student there. At Michigan, I took classes and conducted research with two different mentors. First, with Dr. Preeti Shah, I worked on ADHD research. I helped with an intervention for kids with ADHD, and I developed projects on hyperfocus in ADHD, or how people with ADHD have a unique ability to focus really hard on certain tasks that they enjoy. Secondly, in Michigan, I worked with Dr. Rachel Seidler to study how our brains coordinate and control the way that we move. Dr. Seidler then planned to move her lab from the University of Michigan to the University of Florida, and she invited me to come with her. So after a full winter of shoveling snow in Michigan, I was very excited to make the move. So this is what brought me to the University of Florida, where I'm currently finishing up my PhD. So with Dr. Seidler at UF, I've worked on two main areas of research. First, Dr. Seidler has several big grants from NASA to study astronaut brains. Specifically, we want to know how the brain changes when we go to space. This is really important to understand if we want to get folks to Mars. We want to know that they'll arrive there healthy and that they'll return safely. So when someone goes to space, they're exposed to all sorts of different challenges, like microgravity, radiation, isolation, and many other things. And when folks come home from missions, they experience various problems, like a lot of difficulty walking and balancing normally. So this is an astronaut from soon after they return from the International Space Station. And you can see that they're having pretty obvious trouble walking. So we use MRI scans, or magnetic resonance imaging scans, to take pictures of the brain several times pre and post-flight to study how the spaceflight environment affects the brain. So one thing that we found here is that microgravity can cause your brain to actually shift upwards within your skull. So you can see that here. From pre to post-flight, the brain squishes up against the skull. And then another thing that we see is that post-flight, astronauts' ventricles expand. Your ventricles are a part of your brain that hold fluid. We think that spaceflight prevents fluid from draining from your brain normally. And then after astronauts return to Earth, it can take a long time for their ventricles to recover to their original size. We're still working on this research, but we think that some of these brain changes with spaceflight are really important and that they might relate to some of the performance problems that we see, like the problems that astronauts have with post-flight walking and balance. In addition to studying astronauts, we also conduct analog studies that try to mimic some spaceflight conditions here on Earth. Specifically, we're involved in a few projects where we ask folks to lay in bed for up to several months at a time. They lay with their head tilted down a bit the whole time, and they don't get up for anything. This is similar to spaceflight because laying down for so long takes all the weight off of their bones and muscles, and having their head tilted down tries to mimic how a lack of gravity in space can cause fluid to shift towards the head. Similar to our astronauts, in these bed rest studies, we take images of the brain in an MRI scanner to understand how the bed rest environment affects folks' brain and their ability to perform cognitive and motor tasks. My second line of research at the University of Florida involves studying a different perturbation of the brain. So that is, I study how getting older affects the brain. My particular focus is on healthy aging, so on folks without any diagnosed diseases. In this work, I've tested both young and older adults, so college students and folks about 65 to 90 years old. I collect a bunch of different brain images in the MRI scanner, including images of brain structure, brain function, and brain chemicals. And I also do brain stimulation to study how motor pathways that go from the brain to the muscles change with aging. So for instance, here on a young adult participant, I'm stimulating their scalp with what's called transcranial magnetic stimulation, or TMS. And here I'm targeting a part of their brain that controls their finger and hand movement. As you can see here, my stimulation pulse has caused their finger to twitch. So I take a number of different measures using this type of brain stimulation. For instance, I measure muscle activity while participants do different computer game-like tasks on a computer screen. A main goal of this work is to understand how brain changes as we get older contribute to the walking and balance problems that many folks encounter as they age. So I also collect different types of walking and balance assessments on my participants. For instance, I asked participants to walk on a treadmill that's split right down the middle, where the left side moves 2 times as fast as the right side. People can get used to walking on a funky treadmill like this, but folks vary in how quickly and how well they're able to adapt to it. My goal is to study how brain changes with aging relate to performance on mobility tests like these, to understand the brain mechanisms that might contribute to the walking and balance problems that we see in otherwise healthy older adults. So overall, my day-to-day life as a PhD student varies a lot. My main goals are to work on these research projects that I just described. So that means setting up experiments, getting them approved, recruiting people to participate in the experiments, and collecting the data. And then I spend quite a long time in front of a computer processing the data, running statistical analyses, and writing papers about my research. So no 2 days working on research are exactly alike. And then in addition to my research, I spent about the first 2 years of my PhD taking a variety of science and statistics classes. And I spent some time in the past teaching neuroscience classes to undergraduate and graduate students. I've also had a number of really neat opportunities to travel. I presented my work at a bunch of conferences attended by hundreds or thousands of scientists, and in places around the US like San Diego, Boston, Houston, and Santa Fe, and in places around the world like Ireland and Japan. I don't have a ton of free time as a graduate student, but in the time that I do have, I enjoy spending as much as I can of it outside, kayaking and scuba diving. And I also enjoy working on STEM outreach efforts for young people in the local Gainesville community. Additionally, enjoy fostering kittens and hanging out with my rescue cat, Yeti, who always loves to help me work. And soon I'll be graduating from the University of Florida with my PhD. My next job is going to be working as a postdoctoral fellow, where I'll get more training in conducting neuroscience and aging research. And then my ultimate goal is to become a professor and run my own research lab at a big university like the University of Florida. So thanks for listening to my story. I hope it gave you some insight into what it's like to be a PhD student at UF and that you enjoyed it.